I don't know why. I know I mention that every single time. Okay. All right. You guys remember this now. Those that had me last year on what I did to start this video for those that are actually absent, there are some people, I don't know if they're coming back to school, right? These people in fifth hour. But we played these two of the three videos. Feel free to watch that middle one too, if you're at home, about what a radian is. And students I had last year, we actually did do that. You actually saw those exact same videos last year. I started with that. All right. So just wanted to make sure we're in the right spot here. Make a point of this. Why and students are like, this is so stupid. Sometimes they say that. Why do we put angles in a coordinate plane? Who cares? Why are we doing that? Isn't Earth in a coordinate plane? What is that coordinate plane called with L's, the two L's? Latitude and longitude. And why is it used? To find specific positions. All right, and that's what it's used for. Last hour I came up with the idea of, hey, I want to go to Mars. Do you just go there? Oh, it's right there. Let's just go there. What's going to happen? We're what, and Mars is what? We're all what? Moving. So for us to go to Mars, we may have to start going that way and meet it and understand where that's going to be. And that's a whole bunch of planetary motion. That's a whole bunch of coordinate planes, but moving at the same time. Remember I told you about the airplane and all the instruments in there? You know, we did a little angle of depression with an airplane, but everything's moving. So that's why there's multiple instruments calculating all the movements all together. But really, probably behind the scenes are some coordinate planes to determine positions. And that's the best thing I can explain. So that's why coordinate planing and angle measure is actually a really powerful thing. It's probably one of the most important parts of trigonometry. Coordinate plane trig. It really is. All right, so we have to have some rules. Rule number one is standard position. I don't know why this is a thing. The pen. See, just got to hit it really hard and then it works. The initial side, somebody decided, let's make that the positive x-axis. Got it. And then the terminal side is wherever the angle ends up. So that's the second side. In this first one, I grab my highlighter. You better highlight that. Whenever I go counterclockwise, then that angle measure is determined to be positive. It's just a decision somebody made. You need to memorize it. All right? Now, it's so weird in math, counterclockwise seems to be the norm. I always think positive normal, negative abnormal, or positive the regular way, negative the opposite way, you know, just in my mind. So therefore, if I decided to go clockwise, then that angle measure is negative. Yet again, the initial side has to be the positive x-axis. And then therefore, you're going to be given angles in standard position, and you need to know what quadrants we land in. I guess I went a little fast. I asked what quadrants we have. What quadrant is this, everybody? 1. Where's 2? Left or down? Left, yet again. The pen just stopped. You know what? I quit. I'm done writing. Oh my God. This is 2. Yet again, clockwise seems to be the norm. You number this clockwise, counterclockwise. My bad, dogs. I said clockwise. There's mistake number 1. Some people in this class put little tick marks. There's one mistake by Mr. Samuelis. All right. I can see you over there. Okay. All right. Anyway. So how many degrees are in a full circular rotation, everyone? Huh? 360. Got it. Okay, so then where does 60 degrees land? What quadrant, everybody? 3, 2, 1, go. 1. Wouldn't you agree that that's like somewhere right around here, right? 60 degrees. Now, AP in trig, you're only going to see radians. That's all you're going to see. But I'm still going to keep bringing up angles and degrees. All right, it's a mistake for you to move on in your high school career, not know what angles and degrees are compared to radians would be a problem. All right, so I'm going to constantly keep bringing up when we talk about radians the degree counterpart. Where does negative 90 land? Let's just say this: up, down, right, or left. Where do I go? Down, because this is negative 90 and it goes in this direction. Again, This is always the initial side because somebody said so, and we must follow the rules. All right, where's 240 land? What quadrant? 3, 2, 1, go. Ooh, nobody answered. 3, 2, 1, go. 3. Why? We know this angle measure is what? What's this angle measure right here? This is 270. 90, 180, 270. So 240 is like right there. So drawing these, knowing where they're located, very important. Where's negative 270 land? I'm going to give it fast. Up, down, right, left. Up. Okay, so it ends up here. 90, 180, 270 in a clockwise direction. So the ability to do this is going to be very important. Okay. All right, what does it mean for an angle to be 1 radian in measure? This is why I showed the video in the beginning. Those that are at home eating bonbons while they're not in school. Anyone know what a bonbon is? They're delicious, little chocolate-covered ice creams. Anyway, I used to make that joke all the time back in the olden days. That is this. Oh, okay, so what is this? Whatever this is the same length. So if this was 3 inches, then this is 3 inches walking along this arc length. And then therefore, when I put this terminal side, that is 1 radian. And then the first video explains 2, 3, 4, 5, 6 radians perfectly. Second and third, a combination of 2. Third one explains why 2 pi is a full rotation. So if you don't watch those at home, you're doomed. All right? Doomed. Doomed. What is the definition for the measure of an angle in radians? What are we talking about there? Sorry, sometimes I just got to make sure I don't make a mistake here. Oh, yeah, I don't like that definition. So I think I skipped that last hour. Okay, so what is the definition of the measure of an angle in radians? It's just how many times we have an arc length equal to the radius. So if I have 2 arc lengths worth of radius, that's 2 radians, so on and so forth. This is what I did last hour. I said, watch the videos. Watch those 3 videos, and then that's what the definition is. How many radians are in 1 revolution? 2 pi. How do we know this? Watch the video. That's why I spent that time. They're awesome. They're great animations. Okay, then from those videos, if you don't stop this video and watch those, this next part's not going to make any sense. We're talking about people at home. Okay, so the first circle I have here is this is 0. And then what did we find out from the video? What does that angle measure? What does that angle measure? What's a full rotation? Not 360 in radians. 2 pi. We got to do radians. Yes, it's 360 in degrees. You're right. And I said I would do the corresponding degree measures. Okay, but then what's this one? I'll stay green. Maybe I'll go blue, and then green will be. What's that in radians then? Pi. And they actually did write that. They did write. Actually, I should put it here. This is pi. But often we put the angle measures listed off to the outside of the circle. And that's how we're going to do it on the last one, because we really can't put it on the inside when everything is in the way. Okay? And then what's 180 the same as? How many degrees? What's half of 360, everybody? 180. And that was written in the third and definitely the second video, but you didn't get to see that one. Okay, so that's what we said about those questions up there. I decided to do that. All right, let's pick a color here. I guess I'll just stick with red. Okay, all right, so we already got this. This is pi radians. I guess I could put this right here. This is 0. I won't do degrees except for our new ones. This is 2 pi. Was that a hiccup? Do I have to scare someone their hiccups away? We'll wait. Okay. All right, so what is this angle measure then? Which is no! Did it work? I scared him, so he will not get future hiccups. What? Does it work that way? All right. What is that angle measure, which is half of that? So what does that become? Pi over 2. So that's pi over 2 radians. This is how we break this down. Whoa, whoa, whoa. Break it down. Anyone know what song that is? Can't touch this. All right. What's this third one? What's this third one down here? 3 over 2 pi. This is someone that's not fractionally challenged. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi. Isn't this 4 pi over 2? Isn't that 4 pi over 2? This is why radians are not hard unless you can't do a fraction. That's why when we go to the AB class, I'm going to be hitting my head up against a wall. All right? Because they'll do, what's 1/2 plus 1/2? 2/4. Okay, I'm all right. All right, so anyway, 0 pi over 2, 3 pi over 2, and then we're going to go ahead and do the degrees that I said here on this one. Hey, what does it look like this is cut into fractionally? What does this look like fractionally compared to this? What fraction of that 1 pi over 2 is that? 1/3. It's cut into thirds, right? Right. So what's 1/3? Here we go. What's 1/3 of pi over 2? What's 1/3 of pi over 2? Pi over 6. I'll do the degrees after this. What's 2/3 of pi over 2? What's 2/3 of pi over 2? And I know you're afraid, how is he getting these? 2/3 of pi over 2, the 2's cancel, right? Right. And then you know what? I'm going to stop. I'm going to do this a different way. You ready? I'm going to come up to the board. Here I come, just so you know I'm in the classroom right here. 1 pi over 6. Are you ready? 2 pi over 6. Is this 2 pi over 6? Is that 2 pi over 6? Yeah. 3 pi over 6. Is that 3 pi over 6? Is that 3 pi over 6? Yes. What's after that? 4 pi over. What's 4 pi over 6? What does that become? 2 pi over 3. What's 5 pi over 6 become? What? 5 pi over 6. What's 6 pi over 6, everyone? 2 or pi. 6 pi over 6. What's 7 pi over 6? What's 8 pi over 6, though? 4 pi over 3. What's 9 pi over 6? 3 pi over 2. What's after 9 pi over 6? 10 pi over 6. And then what's after 10 pi over 6? 11 pi over 6. You were trying to reduce. And then what's after 11 pi over 6? 12 pi over 6, which is certainly 2 pi. Got it? Very simple. And that, as a matter of fact, when we start doing trig on these, I got another way of doing this. You guys know it, and this is why you succeeded last year. I compared every angle measure to either pi or 2 pi. And then we jump backwards or forwards. And if you're not fractionally challenged, radians are the simplest thing in the world. If you are fractionally challenged, then it's equal to doing calculus, for a regular calculus student. I don't know what to do about those students that can't remember from one day to the next, remember their grade school math. It's really why I hate when people say pre-calc is so hard. I know why it is. It's just because of simple things. Hey, by the way, what's 1/3 of 90 degrees? Where's 90 degrees up here? What's 1/3 of 90 degrees? This is 30 degrees. What's 2/3 of 90 degrees? Or we could do this another way. 30, 60, 90, 120. What's after 120? 150. What's after 150? 180. We already know that. What's after 180? 210. What's after 210? 240. What's after 240? Of course we know that's 270. What's after 270? 300. What's after 300? And then I forgot to do this in the other hour. I jumped back to it, though. I definitely did do it. Now let's insert these, which are a little bit different. You go ahead and draw those in there. That. What fraction am I looking at now of those quadrants? Half. What's half of pi over 2? What's half of pi over 2? What's half of pi over 2? Pi over 4. What's half of 90 degrees? We'll do that after. Okay, and then you know what I could do now? 1 pi over 2 or 4. Sorry, 1 pi over 4. Isn't this 2 pi over 4? What's after 2 pi over 4? 3 pi over 4. What's after 3 pi over 4? Isn't this 4 pi over 4, right? What's after 4 pi over 4? 5 pi over 4. What's after 5 pi over 4? Isn't this 6 pi over 4? What's after 6 pi over 4? 7 pi over 4. Now let's get my green for all degrees. What's half of 90 degrees? 45. Is that green? Yeah. 45, 90. 90 plus 45 is 135. 135 plus 45 is 180. 180 plus 45 is 225. 225 plus 45 is 270. 270 plus 45 is 315. Now I'm doing something wrong when I go off of a y-axis. Don't worry about it. When we're actually doing trig, you always have to go off of the nearest x-axis. You hopefully remember that from last year. We're not doing trig right now. We're just denoting what are these angle measures and what their measures are, both in degrees and radians. Okay, so trying to sketch these. Where does negative 3 pi over 2 land then? I'm going to give you a hint. It's up, down, right, or left. Which one is it? Up, down, right, or left? It's up because this is negative pi over 2. This is negative 2 pi over 2. This is negative 3 pi over 2. Got it? Oh, I got something for you. Let's wait to 8 pi over 3. You're going to be so cool with your friends. What's negative 3 pi over 4? Where does that land? Think about it for a second, and I'm going to go right now. 3. Answer me. In 3, 2, 1, go. The new girl didn't answer. What is going on over here? When I say 3, 2, 1, you must answer or else you get in trouble. All right? Right? You got to learn the rules, man. We got to get fast track this. Okay, so where does negative 3 pi over 4 land? 3, 2, 1, answer. Say something. 3. I was asking for a quadrant. You guys didn't hear that? Why is it in quadrant 3? Because this is negative 4 pi over 4. What's negative 4 pi over 4, everyone? Negative pi. So this is negative 3 pi over 4, which is the 45 in quadrant 3. I am going to use that, by the way. Hey, you guys remember me from last year? Yeah, how could we forget? I had nightmares. Do you remember last year, you people that I had, that I highlighted the over 6s as a same color? Because those are all the 30-degree reference angles. Do you remember that? And then all the over 4s were the 45s. Because you're going to have 30, 60, 90, 45, 45, 90s coming up. And then I highlighted all of the over 6s, or I'm sorry, over 3s a certain color. Because those are all the 60-degree reference angles in a coordinate plane. So when I did this, when I made this negative 4 pi over 4 to find out where negative 3 pi over 4, that was the way. That was the way to find out where I was located. Where's 11 pi? Come on, look at your chart. What quadrant? If you don't answer this, I'm going to throw a podium at you. You ready, new girl? All right, so where's 11 pi over 6? 3, 2, 1, go. 4. Good. That's how it works in this class. You have responsibilities in your education. Isn't that what it says on your sheet? Unless you don't take your notes because you're yawning away over there. All right. What's 8 pi over 3? Hold on a minute. What's wrong with 8 pi over 3? It's big. Anyone big? Anyone bigger? Bigger than 1? I got a little tickle in my throat. Drink time. Let's go. Who's got drinks? Let's go. Cheers. You got one? All right. Let's go. What was I looking for? 8 pi over 3 is bigger than 1 rotation. Here's what you do with this. Okay, drink time's over. Put it away. What's 6 pi over 3? What does that equal to? 2 pi. What's left over? 2/3 pi. So new girl, oh, I hate this class. Where does 2 pi over 3 land? What quadrant? 3, 2, 1, go. Second. So you go, this is what, oh, and then here's where you become cool. What's it doing outside right now? So exciting. Oh my gosh. I hate that feature. Okay, what's it doing outside right now? Snowing. So here's where you can become cool. What do you do in Walmart's parking lot when it snows? You do donuts. Ooh, that's an illegal student over here. She said that right away. You do donuts in the parking lot. So what do you do with your friends? Hey, when you do a first full circle, I just did a what? Now when you're with your friends doing donuts, you go, hey, oh, I was just in the middle of a joke. All right. No, Kennedy and Vincent's. I don't know. Wait. Yeah, you weren't here. Yeah, so I just go and tell them that. Vincent, do you know how to scan in? All right, have a good one. Where was that? Oh, right. Let's go back to the joke. We always have interruptions like this in a standard school setting. So you do your full circle and you go to your friends. I just did a 2 pi, baby. No? Anyway, right? 2 pi. Where did I lose my pen now? I started these interruptions. All right. Pen. So, ruin the joke. It's all about the timing. All right. So, my point is this 8 pi over 3 is different than 2 pi over 3. Because 8 pi over 3 is more fun in Walmart's parking lot. You do an extra spin, right? Okay. So, that's what you need to understand about that. Okay, key facts. Always had to think. Okay, and this is what Cooper and Gray were talking about. Key facts. It was in our videos. Both of them had this, I think. No, the first one didn't. The first one was just in the animation of but he did say it. No, he said 2 pi is 360. So, and then it's very simple. The second video had this, and it just threw it at you. The middle video explains it a little bit more. It's not really that important. I do like the middle video. It's just a little bit longer, and it puts them both together. So just look at it after this. It'd be a nice little closure, probably the whole idea. But if I take and divide this side by pi, then 1 radian equals 180 degrees divided by pi, right? Right? If I divide both sides by pi. But then if I go the other way and I take this 180 and divide it by 180, then I have 1 degree equals pi radians over 180. And that's what the guy just shoved at you at the end. Because he did show this equation, which was true. This is how you convert degrees to radians and radians to degrees. All right? And understand that you're in a different world now, especially those that didn't have me last year. What's wrong? Did I do something wrong? Yeah. Okay. We don't need these conversions. Look at your little circle. What's 150 degrees? What was that in radians? What was that in radians? 5 pi over 6. Guess what? When I multiply this by pi over 180, the zeros cancel. 15 over 18 is 5 over 6. Huh? What's negative 45 degrees? Think about it just going directly down. What would that be? Negative what? Pi over 4. Watch when I multiply by pi over 180. Darn tootin', you get a negative, and these cancel to be 1 over 4. They even give you a pass? I love the dean's office. They're the ones that don't give passes. I just don't get it. Rules. All right. And then 450. Let's think about 450 for a second. Isn't that 360 plus another 90? Right? So what's 2 pi? Isn't that 4 pi over 2 plus pi over 2? Which is what? What's 4 pi over 2 plus pi over 2? What's 4 pi over 2 plus pi over 2? 5 pi over 4. No! Go to AB. 5 pi over 2. Okay? If I multiplied this by pi over 180, you would get the same. Okay, now this is what I really love. 107 is not one of those unit circle, nice, perfect values. Get your calculator out, and then I'm going to blow your mind. Before this, though, don't you agree that 107 degrees is like right here, right? What do you expect before you touch any buttons on your calculator? How many radians do you expect? Is it going to be greater than or less than 1? First of all, that's my first question. Greater than or less than 1 radian. We should be able to answer that from the animation. Greater or less than 1? Greater. What do you think? Greater or less than 2? Now, that's a tougher question, isn't it? So don't you expect an answer around 2? Remember the animation, 1 radian, 2 radians, and if you don't make connections. Okay, that's what kills me with the AB students. They don't care about this connection thing. That's why they don't know what they're doing. All right? When you don't watch. Ugh, so frustrating. But now this one, you want to do pi over 180 as all decimals. You want to type this on your calculator and press enter. And then make total sense of your answer if you truly watched and understood the first video that I showed you. And then what do you end up getting? Anyone? 1.8. I can't hear you. You're like on your deathbed. 1. What's the answer? 1.8 what? 7. So radians don't always have to have pi in them. As a fat or a mac, we could turn these into decimals. All right? Like this one would be a good one. 5 pi over 6. Type this as a decimal. I didn't do this last hour, but I want you to make sense out of this. This is going to be close to 3. Why is it going to be close to 3? Because the animation showed that 5 pi over 6 from here to here was close to where 3 radians landed when he was doing the animation with the radius being slapped on the circle. What do you get when you take 5 pi over 6 as a decimal? Did someone do that for me, or we start looking at each other awkwardly? 2.62. I expected a little bit bigger, but no, I guess that makes sense. Okay, 2.62. Not 3 was really close to 3.14. So that's why this is 2.62 radians. You don't always have to have pi in radians. Just when we have these exact values, we end up doing it. Hey, what's 3 pi over 2 end up becoming? Let's check my time there. What is 3 pi over 2? How many degrees? Look at your circle. 270. All right. Well, guess what happens when I take 180 divided by pi and multiply this? The pi's cancel, and 3/2 of 180 is 270, right? So look at the circle. Now we're doing our conversions. What's negative 7 pi over 4? Don't say 45. It's negative. Look at the positive, almost full rotation in degrees. That's an over 4. 315. Okay, so it's 180 divided by pi. Multiply. And there's another indication. When do I know to use 180 over pi? The pi's cancel. And that's a good thing. You know what 7 pi over 2 is? It is 4 pi over 2 plus 3 pi over 2. So first of all, where would you land? Up, down, right, left. If I was going to draw 7 pi over 2 out, where would I land? Up, down, right, or left? Down. I'd end up down here after a full rotation. Okay, but if I multiply by this, so you know what this is? This is 360 plus 270. 360 plus 270. So I'm trying to make all these connections, which was what, 630? Is that right? Okay, this just seemed weird to me. And then 3 radians. Look at where 3 radians was from our animation. It was 1 radian, 2 radians, 3 radians, right? Wasn't that where it landed in that animation, correct? So what can we expect as an angle measure? A measure less than 180. So go ahead and type that on there. Type 3 times 180 and then divide that by pi. And you're going to get 100, probably 170 some degrees. 172 what? Okay, and that's where we want to make that connection. But hopefully you didn't draw on there. We already drew the what 1 radian is in one of the questions here. Okay, so here we go. And I don't care what you use. I know someone in the last hour said, I'm just going to use the first formula. Fine. All right. But here's what arc length is. It's not a fraction of the circle. I'd rather say something. It's kind of true, but it's a fraction of the circumference. So I do want to do a drawing of this. And I like doing quadrant 2 drawings. So if I have this and I have like this, and this is theta, whether it be in degrees or radians, this is the arc length, the distance that you walk from edge to edge there. Circular. You've walked on circular paths before, curved paths. Don't all have to be straight, but even though they're curved, there's a distance that you walked. So this is the circumference, this is the arc length, and it's in, no, I want parentheses. This is in terms of like feet, inches, miles, mi, or it could be, let's give what's that other thing called? Kilometers, the metric system. Let's give them a little press. You know, I've learned on YouTube we're one of only 3 countries that uses the English system. You know, the feet, miles, inches. We're weird. The other 2 are very small countries too. It's kind of strange. I forgot what they were. Belize maybe is one of them. I don't know. I don't know if I'm right or not. Okay, so here's arc. By the way, you know what arc length is noted as? Put this here. The letter S. That's what arc length is noted as in many books. I don't know why. All right. But I'm going to use that from here on out. Arc length is S. And in your old geometry concept, it was this. It was what circumference of a circle again? We already mentioned it. 2 pi r. But that's a full circle around. So when the angle was in degrees, we had to multiply this full circle by a fraction. The angle itself tells me the fraction. But what's a full circle? What's a full circle in degrees? So this fraction was whatever the angle is in degrees divided by 360. Now what I want you to understand is when we're looking in radians, the angle already tells me what fraction I'm dealing with. What? What's 2 pi? How much of a circle do I have? What circle? Full. What's pi radians? Half. What's pi over 2 radians? A fourth. So actually arc length, when your angle is already in radians, it's already there for you. So it's theta times r. And then notice when I put 2 pi in, just make the correlation. If I put 2 pi in for theta, how much of a circle do I have? The whole. And then you end up with 2 pi r, which is the whole circumference of a circle. If I put pi in here, how much of a circle am I dealing with? Half. The angle in radians already has the fractions determined. Got it? So you have to understand that, though. These formulas are completely different because this is when the angle is in radians. Got it? We have a simple way of dealing with only this thing. If you want to keep dangerously working with this one, fine. It's okay. It just seems to be, well, I don't think it's that hard. So either or. I don't want to, you do what you want. But what is the length of an arc subtended by an angle? Subtended means like cut, this cuts this by an angle, pi over 2 in a circle with a radius of 6 meters. Okay, well then that's what you got to understand then. This is ready to just plug in. The angle's in radians, so it's theta times, make sure you read. I am more than happy to tell you that I made 2 mistakes last hour. Not yet. I think it's coming up. And then this is 3 pi meters. What does that even mean? Well, go ahead and hit 3 times pi. Do it real quick on your calculator. And then I'm going to hold up a yardstick, which is close to a meter stick. 942 approximately meters. This is a yardstick, which is apparently about 8 milliliters off of a meter. Let's pretend this is a meter stick. That would be 9 of these that you walked along a circle. So it's an actual concrete length. Right? So if that circle was that large, that's what you need to understand. So when the angle's in radians, pi r. So crazy. But that already has factored in that I'm only dealing with a fourth of a circle. All right, so that's why it doesn't matter. Now this is where we get a little crazy. A pendulum swings at a 27 degree. Sorry, I did it again. 72. I did that mistake last hour. I did 27. I did it twice. All right, how far does the tip of the pendulum travel in one swing? So what's this distance? And this is 2.5 meters long. Okay, so this is how we do this if we're going to stick with theta r. Well, first of all, r is 2.5. Time check. Oof. All right. And then 72. No, you can't just type 72 in here. Here's what you can do if you stick with the idea, wait, I need to convert 72 degrees into radians. That's what you do. You just convert it to radians by your 180 over pi thing. I'm sorry. Wrong. What did I do wrong? It's pi over 180. My bad, dogs. How I caught myself is pi is usually up in the numerator when you're in radians, so I know it's that conversion. Or here's another thing. Dimensional analysis, the degrees have to cancel, right? You know, dimensional analysis, you multiply by a dimensional, and then a certain thing has to cancel. So that's another discount double check. Get the decimal answer, it's it, okay? We don't have to do the calculator. Got it? You understand? Now, I know you can do the other one, 72 degrees divided by 360 times 2 pi r. Same thing's going to happen. Got it? So you could have done 72 over 360 times 2 pi, 2.5, and you would have got the same answer. All right, so you do whatever you want. I couldn't. Anyone? No, and this was a disaster. I made a couple mistakes on this one. Here's mistake number one. I didn't even, no, and some of Kurt's, it was Kurt's. Kurt's like, yeah, I knew it. I just didn't feel like telling you. Like in the middle of it. Thanks a lot, Kurt. Much appreciated. All right. Then he was making fun of me with all of his other friends. Here's mistake number two. What do I actually need? The radius. Actually, I did not make that mistake. That's not a, I can prove that. I can prove that. See that 8.5? Right. So I did not make that mistake. So that was a lie. Okay. So wait a minute. A particle moves along the edge of a circle with 17 inches in diameter. How many revolutions does it take for the particle to move a total of 15 feet? That's the arc length. And what you have to understand is here's circular movement. So here's the circle it's traveling along. Let's pretend it started here. It could have traveled many revolutions and it just keeps going. Isn't this what an electron does? Doesn't an electron move around an atom, right? All right, and it keeps going around. So here was number one. What should I do with 15? I should multiply it by what? 12. Do that real quick. I can't think right now. I've made so many mistakes today. Huh? 180? That's it. I should have been able to get that. That is the S. That is the arc length. And then theta R. And that's what we're trying to find, theta. And then we're going to do some dimensional analysis. And then I did not do this wrong, but I will write it weirdly like this, theta R. Okay, that's, takes the place of 2 pi r when you have your angle in radians. And then this is in inches. So that was number one. Divide by 8.5 inches. Do that real quick. I knew the answer was quite small, and it didn't make sense last hour. And then what does that become? 21 what? Okay, keep that on your calculator. That's in radians. Got it? Now we're going to do dimensional analysis because I did not make this mistake. I made a mistake in the 180. I put 15 there like a fool. How do I get revolutions out of radians? Dimensional analysis. I take 21.18 radians, and then how many radians are in one revolution? How many radians are in one revolution? No, how many? Okay, yeah, you did it as a decimal, but let's do it perfectly. What's one revolution in radians? We said it 32 times today. 2 pi. And why is that going to go on the bottom? What has to cancel? What word? What word has to cancel? Radians. And what has to be left over? Revolutions. We're not converting to degrees. We're converting it into revolutions. Now, this is funny. Last hour, people did not, you know what they did? They typed this on their calculator. Divided by 2 pi, exactly like this. What's wrong with that? What does the calculator do? It divides by 2, and then what does it do? Multiplies by pi. So you have to divide by 2 pi with parentheses. What do we get for that? You know 6.28 is one revolution. 6, 12, 18. I'm expecting 3 point something. 3.37. So it's also expectations. Got it? Okay, we're running low on time. What's area of a circle? What's area of a circle? Pi r squared. Okay. What's area when we were in degrees? It was theta divided by 360 times pi r squared, right? That's when you have an area of a sector, correct? But then when I have the angle itself all taken care of, that area in radians is half theta, as long as this is in radians, r squared. Why? Just humor me. What's a full circle again? What's a full circle? 2 pi. What's half of 2 pi? Pi r squared. See that? So when I put 2 pi in there, I get my full area of a circle. So that's why that half is in there when your angles in radians. And then you have more of the same. Up, the angles in degrees. So either use this formula or convert this into radians. Woo! That's a mouthful today. Okay, all right.